So hello and welcome to another podcast for National Insect Week 2014. I'm joined by Camille Parmesan today, who is a professor at Plymouth University, and she has worked extensively on a range of organisms, but luckily has heavily been based with insects, and particularly climate change has been a lead thrust in her research. So thank you, Camille, for joining me today.
You're very welcome.
So, first of all, could you please describe to us your research with insects on climate change and perhaps the kind of findings that you get out of your work?
Well, I've been working with a particular butterfly called Edith's checker spot that lives in the western part of the USA. And I've been doing basic ecology, evolution, and behavior with this butterfly for several years, actually, for my PhD. And this was in the mid-1990s when climate scientists were not yet sure that they were finding a significant warming. They expected it from basic principles, but they weren't sure they were yet finding it. And here I was working with this incredibly climate-sensitive butterfly that we knew was climate-sensitive because of work going way back to Paul Ehrlich in the 1950s, that the population numbers go up and down with yearly variability of climate. And I thought, here's this very climate-sensitive organism. You know, if anything's going to be responding to subtle changes in the climate, it's going to be this butterfly. So I got funding from actually the NASA Mission to Planet Earth program and set out to do what was really an incredibly risky project, which was to try to see whether this butterfly was showing a response to climate change in terms of some patterns of population extinctions that we might be able to relate to long-term, regional-scale climate changes. And we knew that extinctions are quite frequent in this butterfly, so I knew I'd find extinctions in natural habitats. But what you're looking for is a particular pattern that would link it to climate change, and that pattern in particular is that we expect poleward, northward, and upward range shifts of species that we saw during the glacial interglacial periods. So when glaciers came down, species would go downhill and towards the equator. Glaciers recede, it gets warmer, species go towards the poles and go up the mountains. Very simple expectation. And I went out, spent 4.5 years doing field work, recorded lots and lots of population extinctions in areas where the habitat was still gorgeous. And what I found is that in the southern part of the range, about 70% of the populations had gone extinct down in Mexico and Southern California, in areas that were absolutely beautiful, lots of host plant, lots of flowers. You go all the way up to Canada, less than 20% had gone extinct. And you get this same cline of extinctions with elevation, that lower elevation populations were about 40% had gone extinct, yet you go up to the highest mountains of the Sierra Nevada, less than 15% had gone extinct. So the average location of a population had moved northward and upward, lo and behold, by exactly as much as you'd expect from the 0.7 degrees centigrade warming that had occurred in the western half of North America.
So these butterflies were tracking these cooler climes. They were finding refuge in these cooler climes.
Yes, the species as a whole was tracking, but what a lot of people get confused about is they think an individual butterfly gets hot and moves, and that's not the process. It's a much, much slower process of populations where the climate is gradually deteriorating, going extinct, and gradually at those northern range edges in Canada and at the very highest elevations, populations are doing really well, and one would randomly start colonizing northward and upward. And that colonization process we're actually be able to see in the European databases, which are much, much better. So in Edith's checker spot, you go to the northern range boundary in Jasper National Park in Canada, and there are no roads, there are no butterfly collectors. It's impossible to know whether they're expanding further northward. So to get more data on more species, I went to Europe, where, for example, in the UK, where practically every butterfly is now and has been over the last at least 100 years, and some records go back more than 300 years. So in Europe, in Sweden and Finland and the UK, I was able to pull together data, and this included 12 other European Lepidopterists. It wasn't just on my own. I was able to pull together data from these areas where we were able to show this northward expansion by up to 200 kilometers over as little as 20 or 30 year period. So it was really exciting that I started with one Edith checker spot that was known to be very climate sensitive and indeed found the northward and upward range shift we expected. Go to Europe, where we didn't know as much about all these individual species in terms of how sensitive they might be to climate, and found out that, lo and behold, 2/3 of the species were expanding northward, and some of them were moving upward as well.
So this paper was a real alarm call that not just this species or that species needs help. There's a hell of a lot of species that are responding to climate change, and it sort of triggered a lot more work on these distribution shifts and even timing. They can change their timing as well, can't they?
Yes, the other big change besides the changes in distributions are changes in especially spring events, like timing of breeding, arrival of migrant birds, calling, the breeding calling in frogs, and that's advancing by about 2 weeks over the last 30 years. So we're seeing the two big changes we're seeing are changes in timing, especially spring timing, and changes in distributions. And coming back around to why insects, that the butterfly range shift that I documented in the Western USA was the first evidence, the first publication of a species changing its entire range in response to regional warming. And it's not really a surprise that it's a butterfly, because butterflies are very sensitive to temperature and climate fluctuations from year to year. So they're what we call a very good indicator species for climate change. They're far more sensitive than a lot of other organisms, and they're able to express that sensitivity by these sort of colonization and extinction events that in ways that a lot of other organisms have too long a lifespan to be able to have that kind of dynamic. So a lot of the early studies that were some of the best studies of climate change impacts have been with butterflies, with fruit flies, with a lot of with mosquitoes.
Mm-hmm. Okay.
A lot of them are with insects, because a lot of other organisms either aren't as sensitive to climate, or it's simply very, very difficult to gather the data. We have very little data on this type of thing in, say, mammals, because we just don't have the kind of monitoring schemes for rodents that we have for butterflies, and it's much harder to gather the data.
So this is one great thing I was going to ask you. So how did you first come to work with insects? But is it because they're just so useful to answer the questions that you find most fascinating?
They are so much easier to work with. I mean, some of the butterflies I work with, I mean, what we say is they drip data. You go out, you get data, you have a paper. And I've worked with other organisms. I did some work with birds, with nesting behavior of birds. And I'd have to get up at 4 a.m, which is not very pleasant. And I would do this every day for a 2-week period, working with a team, actually, several other people. And after 2 weeks, we would get one data point. So it would take years to get enough data to actually publish a paper. And then I worked with primates, and I was doing a behavioral project. And my first day, I go into the room, and it's because they're primates, they have to be kept in cages, and I'm trying to study behavior, and I'm realizing that they're in such an artificial environment, and they're such intelligent beings that I simply didn't trust what I was getting out of it. And then I had an opportunity to work with this butterfly, Edith's checker spot, in the mountains of California in the summertime at 2,400 meters. Woke up every morning to beautiful snow-capped mountains surrounding me. They didn't start till 10 a.m., so I didn't have to do anything with the butterflies till 10 a.m. They quit at 4 p.m., so you could then have a lovely sunset walk and have a beer around the campfire in the evening. And after 2 weeks of this, I had enough data to publish a single-authored paper in a major journal as an undergraduate. And I thought, butterflies are definitely better.
If that is an incentive for students, then the early mornings are definitely an incentive not to work with birds, I think. So that is absolutely fantastic. So what stands out to you as one of your leading memories, your best insect encounter?
Well, for me, there isn't really a single moment that stands out for me, to be honest. But the reason why I love working with them and why it's important to me, not just as a professional but as a person, is that in collecting all this information, it involves going out really into the middle of nowhere where there are no hotels, there are no towns, and so we have to camp out in tents, and your whole life is reduced to the back of a pickup truck. And I found that routine of waking up from my tent literally with the sunrise and going out, cooking over often either a little campfire or a camp stove, and then doing my work and coming back at the end of the day, walking 100 meters to work with my butterflies, coming back at the end of the day to my campsite, getting a fire going to keep warm, and literally going to bed as the moon is rising. That routine I found to be, it's almost a Zen experience. Working with the butterflies and gathering the data is the professional reason, but honestly there's a much deeper personal reason, which is I feel that routine helps center me as a human being. And by doing that and actually living with the butterfly population, you do get a very deep intuition, a deep understanding of what's important to them. And so when I was doing the climate change project and going into areas and trying to document whether or not the population might have gone extinct, I would go in and not find any adults, and I'd be going at the flight season, and I could look at the flowers and I could say, this is definitely should be the flight season. Their host plants are at the right stage. And that level of understanding, being able to go into a site you've never been, know whether the habitat is suitable, know whether you're there at the right time, and know exactly what stage of the organism you should be finding, whether it's caterpillars or eggs or the adults, that's something that only comes from really living there and living with them and seeing them go through their whole life cycle on a day-to-day basis over their whole generation time. And so it's not something you can do from a computer.
So these insects, working with insects, you really do get a lot of great opportunities just to go out into nature and really understand it through collecting the data yourself.
Absolutely. It's not only an opportunity, but I think it's essential in order to be able to understand the data that you're gathering.
So what is the next exciting direction that your research is going to be take? What's in the pipeline for the next results that you're hoping for?
Well, I'll be honest that the last 10 years or so, a lot of the work I've been doing is what's called meta-analyses, which is gathering data from the literature or from other people's databases, pulling it together into these large statistical meta-analyses, because what we really needed was to know that it wasn't just butterflies shifting their ranges, but is this happening to biodiversity in general? And so to answer that question, you need global databases, you need databases on every single organism you possibly can. And so I've spent an awful lot of time the last 10 years behind a computer, or in front of a computer, I should say, and digging through literature and emailing people and Skyping people to ask for their databases. And what I'm looking most forward to at this point, because I feel like I've done everything I wanted to do with these big global meta-analyses, I've pulled together data for both terrestrial systems, and now I've been part of a marine system group, and we now know that it's not just butterflies. 50% of all species of all kinds, whether it's fish or mammals or trees, 50% of them are changing where they live, They're shifting polewards and upwards. And we know that 2/3 of species, and again it's birds as well as butterflies and flowering plants, are shifting when they live. They're advancing their spring timing for breeding or for flowering or for leafing. And this is happening all over the world. So now that those papers are published, I feel like I've answered those big questions. I finally can get back to camping out in the mountains with my butterflies. And I actually just came back from 2 weeks of field work in the mountains of California, and it was absolutely fabulous. And my butterflies are still there, and I still understand them. And so I'm looking forward to delving into now how the climate change that's already occurring is affecting those same populations.
So this is fantastic. You get to go back to the organisms that really kindled your passion and your heart in this work.
Absolutely.
Well, Camille, thank you so much for speaking to me today. It was great that I bumped into you into the hallway.
You're very welcome, and thank you for being quick thinking and grabbing me.
Thank you very much.